So far in this session we discussed the different units of length and their conversions, isn't it? Yes. Is it clear? Yes. Now let's move on to the next topic, that is measurement of long distances. Measurement of long distances. Measurement of long distances. For measuring long distances, we have so many methods like radio echo method, then laser pulse method, again we have sonar method, we have radar method, we have spectroscopic method, we have parallax method, etc. Likewise, we have so many methods for measuring longer distances. Yes. As far as your syllabus is concerned, yes, you have to learn only parallax method. As far as your syllabus is concerned, yes, you have to learn only parallax method. Yes. But anyway, just for your knowledge, let's try to understand just what is what about all the other methods. Yes. The first one is radio echo method. Yes. How do we measure longer distances using radio echo method? In radio echo method, we either send sound waves or EM waves. Yes. What is EM waves? We will discuss EM waves in detail in some other chapter. Now for the time being, just understand what is EM waves. EM waves are otherwise known as electromagnetic waves. Electromagnetic waves are shortly known as EM waves. So what are electromagnetic waves? Electromagnetic waves are some invisible waves which are formed when electric field couples with magnetic field. When it is formed when electric field couples with magnetic field. Yes. Is it clear? Electromagnetic waves. Now back to our topic. Radio echo method. In radio echo method, we send either sound waves or electromagnetic waves onto the target. Yes, like this. Suppose this is our target and the initial position of the wave, let it be here. Yes. Let A be the initial position. Of sound wave or electromagnetic wave. Yes, whatever it may be. And B is the target. Let it be so. So so in radio echo method, we send either sound waves or electromagnetic waves onto the target, like this, onto the target. Yes. Once the wave hits on the target, it's obvious that it will get reflected back. The reflected wave is collected at the same initial position A. Now we know an equation for calculating or for finding distance. What is it? Distance is equal to speed into time. Isn't it? Distance is equal to speed into time. Yes. So here in this case we know the speed of the wave. We know the speed of sound wave or else whatever or EM waves, isn't it? Yes, we know the speed. We measure the time taken for the reception of the reflected wave. Yes, and using those two values we can calculate the total distance from point A to point B. Total distance from point A to point B, that is total distance from the initial point to the target. Is it clear? Yes. Similarly, in laser pulse method, the procedure of laser pulse method is one and the same. The only difference is in radio echo method. In radio echo method, we send either sound waves or EM waves. In laser pulse method, we send laser pulses. Yes, we know, knowing the speed of laser pulses, and we measure the time taken for the reception of the reflected laser pulse. We apply these two values, or we substitute these two values in this equation and find the total distance. Yes. And in radar method also, we use electromagnetic waves for calculating the distance traveled. The principle is one and the same. In sonar method also we apply the same principle. The only difference is we use sonar method especially for finding the depth of the oceans or seas or any water bodies, and the distance to the underwater objects. Is it clear? Yes. The next method is spectroscopic method. Yes, we can say spectroscopic method is quite different from others. We use spectroscopic method for finding the distance to far off stars, to very far off stars. We use this particular method, and in this method actually we compare the brightness. We compare the actual brightness of the star and the brightness of the star when it is observed from the earth. Yes. So using a color spectrum, yes, we could actually calculate the brightness of the star. Yes. So what scientists do is they first determine the color spectrum of the stars. They first determine the color spectrum of the particular star, and they find the brightness of the star, actual brightness of the star. Then they compare these two brightness, that is the actual brightness of the star and the brightness felt when it is observed from the earth. Yes. by which they calculate the distance to the stars from the earth. Yes. And the last method is parallax method. Yes, let's discuss parallax method in detail. Is it clear, all the other methods? Yes. Just for your knowledge, I discussed all the other methods. Yes. So before going into parallax method, first let's try to understand triangulation method. So yes. So what is triangulation method? Let's try to understand through an example. Suppose this is a seashore. Again, this is a horizon. And there is a ship here in this horizon. This is a ship. Yes. And I want to find the distance to the ship from the seashore. I want to calculate, or I want to find the distance to the ship from the seashore. Yes. So I can measure the distance directly, isn't it? Yes. But instead of measuring this distance directly, what I am going to do is I am going to select two random points on the seashore. I am going to select two random points on the seashore, and I am viewing the ship at these 2 points. I am viewing the ship from these 2 points at two different angles. Let it be alpha and beta. Is it clear? This is a seashore and there is a ship in the horizon. And I want to find the distance to the ship from the seashore. Yes. So I can measure it directly, isn't it? I can measure the distance to the ship from the seashore directly. But instead of measuring this distance directly, what I am doing is I am selecting two random points on the seashore. Yes. And I am viewing the ship from these 2 points at some angle. Let it be alpha and beta. Yes. And by using these angular measurements, I am finding the distance to the ship from the seashore. And this procedure or this method is known as triangulation method. So what is triangulation method? Triangulation method is the process of determining the location of a point. By measuring the angle at which the point is viewed from two known points instead of measuring it directly. Triangulation method, the process of finding or determining the location of a point. So here in this example, the location of the point is the ship, isn't it? Yes, the location of the ship or the distance to the ship from the seashore. By measuring the angles at which this point is viewed from two known points instead of measuring the distance directly. Is it clear? Yes. Is it clear? Triangulation method? Yes. And we can say parallax method is a special application of the principle of triangulation method. So what is the principle of triangulation method? The principle of triangulation method is nothing but instead of measuring the distance directly, yes, we are measuring the angle. We are measuring the angles at which the particular point is viewed, isn't it? Yes. So we can say, as I told before, we can say parallax method is a special application of the principle of triangulation method. So instead of measuring the distance directly, in parallax method also we use the angular measurements. Is it clear? Yes. So now let's see what is parallax method. Yes. Let's try to understand parallax method through an example. So mark a point like this on a wall or any other background. Hold a pen or pencil like this vertically against the point. Now look at the pencil through your left eye, closing your right eye like this. Again, holding the pencil at the same position, pencil or pen at the same position, we should not change the position of the pencil. Closing your left eye, look at the pencil through your right eye like this. Yes. Now you guys might have noticed a shift in the position or a change in the position of the pencil, isn't it? Yes. But actually speaking, we have not changed the position of the pencil. We were holding the pencil at the same position. Yes. So this apparent displacement or this observed displacement in the position of an object, when the object is viewed from two different points is known as parallax. That is, let the point be here. This is the point. So let me diagrammatically represent this particular example. Yes, this is pencil or pen, whatever it may be, pencil. Yes. Now this is my left eye and this is my right eye. Is it clear up to this? Yes. Now I am viewing the pencil or I am looking at the pencil through my left eye. Let it be left and this be right. I am looking at the pencil through my left eye, closing my right eye at some angle like this. Again, I am holding the pencil at the same position. I have not changed the location or the position of the pencil. I am viewing my pencil through my right eye, isn't it? Yes. Actually speaking, I have to see the pencil at this particular position. I have to view the pencil at this particular position. But instead, I observed a change in the position of the pencil like this. When I viewed the pencil through my right eye, I felt the position of the pencil like this. It's here. Yes. Is it clear? Yes. Is it clear up to this? This apparent shift in the position of the pencil. Actually, there is no shift in the position of the pencil or there is no displacement in the position of the pencil. We were holding the pencil at the same position. So this is an observed displacement, and this observed displacement is known as parallax. This observed distance or displacement is known as displacement of the position of an object when viewed from two different points. Here initially we viewed through our left eye, and finally secondly we viewed through our right eye. So two different points is known as parallax. Is it clear? Yes. Then the distance between the 2 points of observation, here in this case the distance between the left and the right eye. The left and the right eye is known as base. The distance between the 2 points of observation is known as base. Now the angle formed between the two lines of sight. Two lines of sight along which the particular point is observed along which the particular point is viewed is known as parallax angle. Parallax angle. Yes. This is the line of sight of left eye, isn't it? This is the line of sight of left eye, and this is the line of sight of right eye, isn't it? This is the line of sight of right eye. The angle formed between these two lines of sight along which the particular point is observed or viewed from the 2 points is known as parallax angle. And using this parallax angle, we measure the distance. In parallax method, using the measurement of parallax angle, using the angular measurement of this parallax angle, we find the distance to the object from the earth, or distance to the object from the point of observation. Is it clear? Yes. Is it clear, parallax method? Yes. Now at least some of you guys might be thinking, yes, how do we measure or how do we calculate the distance using parallax angle? Yes. So in real time situations, yes, we have to measure the distance to the planets from the earth, or we have to measure the distance to the stars from the earth, isn't it? Yes. So let this be a planet or star, whatever it may be, planet. So, and this is Earth's surface. This is Earth's surface. So I have to find the distance. To the planet from the Earth's surface. Is it clear? Yes. So I can measure it directly. But instead of measuring it directly, I am going to measure the angles. Isn't it? Yes. So I am selecting 2 points. Let it be A and B. Let it be A and B. Yes. Now I am viewing the planet. From A at some angle alpha. I am viewing the planet from point A at some angle. Again I am viewing the same planet from another point B at some other angle. Is it clear up to this? Yes. Now in real time situations, we consider either 2 stars or a single star, based on our application. Who has an angle of incidence of 90 degree on the Earth's surface, like this. Far off stars, we consider either 2 far off stars or a single far off star based on the application. Here I am considering 2 stars whose angle of incidence is 90 degree on the surface of the earth, like this. Is it clear? Yes. Now this particular angle is parallax angle, isn't it? Yes. This is parallax angle. Let it be theta. Yes. As I told you guys before, we use this parallax angle. To measure the distance to the planet from the Earth's. Angle of incidence. Yes, we will discuss angle of incidence and reflection in detail in the chapter optics. Now just understand what is angular incidence. What is angle of incidence? Yes, when a light ray hits on a surface. Yes, The angle formed between the light ray, and the normal is known as angle of incidence. Yes. When the light ray hits on a surface, obviously it will get reflected. The angle formed between the reflected ray and this normal is known as angle of reflection. Is it clear? Yes. So here in this case, the angle of incidence of this particular star S1 and S2 on the surface of the earth is 90 degree. Yes. As I told you before, we use this parallax angle to find the distance to the planet from the Earth's surface. Yes. We couldn't take a protractor. And go to space and measure the angle, isn't it? It is not possible. So let's see how do we find the measurement of this parallax angle. We have two parallel lines, isn't it? The incident ray of the star, this particular star, that is this black line. Again this dotted line, these two lines are parallel lines. These two lines are parallel lines, and the line of sight of point A, is actually a transversal which cuts through these two parallel lines. Yes. When a transversal cuts through a pair of parallel lines, yes, three types of angles are formed. What are those types? Corresponding angles, then alternate angles, and co-interior angles. When a transversal cuts through a pair of parallel lines, or cuts through parallel lines, three types of angles are formed. What are the three types of angle? Corresponding angle, alternate angle, and co-interior angle. Yes, listen. What are corresponding angles? Angles formed at the same side of the parallel line, that is either above the parallel line or below the parallel line. Either the angles formed above the parallel line or the angles formed below the parallel line. Like this, angle A, angle B. Similarly on the other side also, either like this or like this. Is it clear? Yes. Now, what are alternate angles? Angles are formed in the opposite direction of the parallel line in a zigzag manner, like this. Either like this, A, or like this. Either like this or like this in a zigzag manner. Angles are formed in the opposite sides of the parallel lines. Now, what are co-interior angles? Co-interior angles are nothing but angles are formed at the same side of the transversal, not parallel lines. Here in the case, what are corresponding angles? When angles are formed at the same side of the parallel lines, we call such angles as corresponding angle. When the angle formed at the same side of the transversal, this is the transversal, same side of the transversal, either these two angles or these two angles are known as co-interior angles. Is it clear? Yes. Now, corresponding angles, the angular measurement of corresponding angles are equal to each other. The angular measurement of corresponding angles are equal to each other. The angular measurement of alternate angles are equal to each other. Again, the angular measurements of co-interior angles are not equal to each other, but the sum of those co-interior angle is equal to 180 degree. That is, suppose these two are parallel lines, we know these two are corresponding angles. Suppose the measurement of this angle is 50, the measurement of this angle will also be 50. If the measurement of this angle is say for 130, measurement of this angle is 130, yes, the measurement of this angle is also 130. Is it clear? Yes. Now, the angular measurement of alternate angles are equal. Suppose this angle is 130. So, this angle will be 130. Say this angle be 50, so this angle will also be 50. Is it clear? Yes. Now this is a pair of co-interior angles, isn't it? These two angles is a pair of co-interior angles. The summation of these two angles, is always equal to 180 degree. Is it clear, guys? Corresponding angles, alternate angles and co-interior angles. Yes. So now let's see some more points related to this. Now, when two lines intersect, three types of angles are formed. When two lines intersect, an angle will be formed. When two lines intersect, an angle will be formed. Yes. The angle thus formed can be divided or can be classified into three types. First one, if the angle formed when two lines intersect is less than 90 degree, if the angular measurement is less than 90 degree, such angles are known as acute angles. Such angles are known as acute angle. If the angle formed when two lines intersect is greater than 90 degree, such angles are known as obtuse angle. Again, if the angle formed when the two lines intersect is equal to 90 degree, such angles are known as right angle. Is it clear? Say for example, if it is given a triangle is a right triangle, means yes, one of the angle will be 90 degree. One among the three angles will be equal to 90 degree. Such a triangle is known as right triangle. Yes, such triangle is known as right triangle. Yes, one among the three angles, if one among the three angles of a triangle is equal to 90 degree, we call such triangles as right triangle. Is it clear? Yes. Now, when lines crosses each other, here in this case there are two lines and these two lines crosses each other. Suppose there can be more than two lines. In this case we have 1, 2, 3, 4 lines, isn't it? 4 lines are crossing each other. So when lines crosses each other, two types of angles are formed. That is linear angle and opposite angle. Yes. What are linear angles? Angles on the same line, either these two angles or these two angles. Say for example, suppose more than two lines are crossing each other, so angles on the same angle like this. Or else you can choose this line, angles on the same line, isn't it? You can choose another line, this line, so angles on the same line. So angles on the same line is known as linear angle. And the angles which are opposite to each other, like this, is known as opposite angles. Is it clear? Yes. So the sum of linear angles is equal to 180 degree. The sum of linear angles is equal to 180 degree, and the angular measurement of opposite angles are equal, one and the same. Yes, is it clear, guys? Yes. Suppose it is given line AB is perpendicular to line CD. Line AB is perpendicular to line CD. Yes. What does it mean? What is the diagrammatic representation of this statement? It will be like this. AB. Is it clear? Line AB is perpendicular to CD means it will be like this. Suppose it is given line AB parallel to CD. How will be? line AB is parallel to CD. Yes. Is it clear? Yes. All these are some basic concepts in maths which we need to know. Yes, which we need to apply in so many areas of the physics. So it's a must to know these basic concepts. Is it clear, guys? Parallel lines, perpendicular lines, right triangle, corresponding angle, alternate co-interior. Yes. Now back to our topic. Here the incident ray of the star and this dotted line, these two lines are parallel lines, and the line of sight of point A, of point A is actually a transversal which cuts through these two parallel lines, isn't it? Yes. Now here three types of angles are formed: corresponding angles, alternate angles, and co-interior angle. Here in this case we need only one type of angle, that is alternate angle. These two angles are a pair of alternate angle, isn't it? These two angles are a pair of alternate angle. So if I know the angle between the line of sight and the incident ray, I know the angle between the incident ray and the line of sight of point A. Yes, I can find the value of theta, or I can find the value of parallax angle, isn't it? Yes. So the angle between the incident ray and a line of sight, let it be alpha, and the angle between this particular incident ray and the line of sight of point B, let it be beta. So using these two angular measurements, yes, I can calculate theta. Yes, that is these two angles are a pair of alternate angles, so the value is equal to alpha. Again, these two angles, this angle and this angle, are a pair of alternate angles, so the value is equal to beta. So what is parallax angle? Theta is equal to alpha plus beta. Theta is equal to alpha plus beta. So this is how we find the parallax angle. This is how we find, or we measure, or we calculate the parallax angle in real time situations. Is it clear, guys? Yes. Now let's see how do we find the distance using this angle. How do we find the distance to the planet from the Earth's surface using this angle? Here in this case, or in real time situations, yes, we are measuring long distances, isn't it? Since we are measuring long distances, we can consider this straight line AB. We can consider this straight line AB as an arc, like this. We can consider the straight line AB as an arc. The length of the arc AB is equal to the distance between the 2 points of observation AB. Let it be B. Yes. Now we know the line connecting any point on a circle. The line connecting any point on a circle, and the center of the circle is known as radius. So this is radius. Again, this is radius, and this is also radius, isn't it? Yes. So here the distance to the planet from the Earth's surface is nothing but the radius of this particular circle, the radius of this particular arc, isn't it? Yes. So I know an equation connecting the angle formed at the center of the circle, angle formed at the center of the angle subtended by. I know an equation connecting the angle subtended by the arc, at the center of the circle, the radius of the circle, and the arc length. Yes. What is that equation? Theta is equal to arc length divided by radius. Yes. Do you remember this? Yes, we have already discussed this, isn't it? Yes, in the first session. In the very first session of this chapter, yes, we have discussed this equation. Do you remember? Yes. So theta is equal to arc length divided by radius. Yes. Applying all these values, or substituting all these values in this equation, I can find the radius. So radius is equal to, so here in this case, what is the arc length? B. And what is the angle at the center, that is theta, parallax angle. So radius is nothing but distance d, isn't it? Distance d. Distance to the planet from the Earth's surface is equal to arc length divided by parallax angle. What is theta is equal to? Theta is equal to alpha plus beta. This is how we find the length or find the distance to the planet from the Earth's surface. Is it clear? Yes. Yes, now let's see some real-time applications in detail. So I have to measure the distance to a planet. I have to measure the first one is measuring distance to the planet. Measuring distance to the planet. So first application is measuring distance to the planet. Yes. So let this point be planet P. So this is Earth's surface. I have to find the distance to the planet and let it be d. So since I am measuring very long distance, yes, I can consider this straight line as an arc, isn't it? Yes. These are 2 points of observation from which I look at the planet or from which I observe the planet. I am considering 2 stars S1 and S2 like this, whose angle of incidence is exactly 90 degree on the surface of the Earth like this. The angle formed between the incident ray of the star and the line of sight of point A is nothing but alpha. The angle formed between the incident ray of the star S2 and the line of sight of point B is beta. And I know the incident ray and this dotted line are a pair of parallel lines, and this line of sight is actually a transversal which cuts through these 2 parallel lines. So a pair of alternate angles are formed, and I know always alternate angles are equal to each other. So I got the measurement of parallax angle theta, that is equal to alpha plus beta. And I know the distance between the 2 points of observation, which is equal to the distance of the length of this arc. So it is b. Here in this case I have to calculate d. I know theta is equal to arc length divided by radius. Arc length divided by radius. So what is here? Arc theta is equal to alpha plus beta. Arc length is equal to b and radius is d. Here in this case I have to find the measurement of d. So d is equal to b divided by alpha plus beta. Is it clear? Yes, this is how we find the distance to the planet from the Earth's surface in real time situations. Yes. Now let's see how do we measure the distance to near stars. When we discussed about spectroscopic method, I told you we use spectroscopic method for finding the distance to far off stars. Isn't it? Yes. Do you remember that? I told you we use spectroscopic method for finding the distance to far off stars. Yes. So why don't we use parallax method for measuring distance to far off stars? In parallax method we know we use the parallax angle. We use the parallax angle for measuring the distance, isn't it? Yes. This angle becomes too small. This angle becomes too small to be measured accurately as the distance increases. So why we are not using parallax method for measuring far off stars? We use parallax angle. In parallax method we use the angular measurement of parallax angle to find the distance to the objects, isn't it? Yes. So this parallax angle becomes too small to be measured accurately as the distance increases. So that's why we are not using parallax method for measuring the distance to far off stars. But we can use parallax method for measuring the distance to almost nearer stars. So how do we measure the distance to such stars? Yes, let's try to understand. This is sun. Yes. This is earth, and we know earth is revolving around the sun, isn't it? Yes. So this is the orbit of the earth. This is the orbit of the earth. So initially the earth was here at point A, and after 6 months the earth reached point B. Is it clear? So this is my star. Yes. This is my star. Yes. So I am viewing the star. From point A first. I am viewing the star, yes, from point A first, and after 6 months I am viewing the same star at point B. After 6 months I am viewing the same star at point B. Is it clear up to this? Yes, in the previous example we considered two stars whose angle of incidence is 90 degree, isn't it? But here in this application, here in this real-time application, we consider a single star whose position is always above the earth. And whose angle of incidence is 90 degree, whose position is always over the earth. Or whose angle of incidence, we consider a single star whose whose angle of incidence is always 90 degree, that is, whose angle of incidence is 90 degree throughout the year. Yes. So the angle formed between the incident ray of star S1 and the line of sight of point A, let it be alpha. And again the angle formed between the incident ray of the star S1 after 6 months and the line of sight of point B is equal to beta. So here actually speaking I have to find the distance, isn't it? I have to find the distance D. Yes. So I got the measurement of parallax angle, that is equal to alpha and beta. Here I know the diameter of the Earth's orbit. Let it be B. Yes. So since here I am measuring long distances, I can consider this straight line diameter as an arc. So that the length of the arc is also B. So applying the same equation, radius D is equal to arc length B divided by alpha plus beta. Is it clear, guys? This is how we find the distance to nearer stars from the Earth's surface using parallax method. Is it clear? Yes. So now we have one more application. Of parallax method, that is, we can find the diameter of the planets or satellites. Using this parallax method. Yes. So how do we find the diameter? Suppose this is the planet. P, and this is the diameter of the planet. And I have to find the diameter. of this particular planet P using parallax method. This is Earth's surface. So the first step is to find the distance. To the planet. Find the distance to the planet from the Earth's surface using the equation, that is distance D is equal to arc length B divided by theta. So once I got the value of D, let it be yes. Here in this case, let it be yes. And the angle subtended by the measurement of the angular measurement or the measurement of angle subtended by the diameter of the planet on the Earth's surface, let it be alpha. Here I have to calculate, I have to find the value of the diameter of the planet. Yes. Applying the same equation. Here I can consider this straight line diameter as an arc because I am measuring long distance. Is it? Here in this case I am measuring long distance, so I can consider this straight line diameter as an arc. The length of this arc is equal to the diameter, length of the diameter. So D, arc length D. So I know arc length is equal to theta into radius. Arc length is equal to theta into radius. In the previous applications, yes, we found the value of radius, isn't it? We found the value of radius, but in this case we have to find the arc length. So arc length D is equal to alpha into radius, yes. So what is this radius? This radius is nothing but the distance to the planet from the earth. The distance to the planet from the earth. Is it clear, guys? Is it clear? Parallax method and some of the real-time applications of parallax method? Yes. Yes. Now let's try to understand parsec. Unit parsec. Yes. Do you remember unit parsec? What is parsec? Parsec is the distance. Parsec is the distance from the sun to any astronomical object. To any astronomical object whose parallax angle is equal to 1 arc second. Do you remember that? Yes. So let me represent it diagrammatically. This is sun. This is sun and this is the astronomical body. Any astronomical body or any celestial body. Astronomical body. Yes. So this is sun and I am viewing this particular astronomical object, astronomical body from the earth's surface like this. So initially the earth was placed here and after 6 months it reached at the diametrically opposite point. Yes. So the orbit of the earth's planet earth will be like this. Yes. So here I am viewing the astronomical body. I am viewing the astronomical body from the point A initially. After 6 months, I am viewing the same astronomical body from point B. That is diametrically opposite point, isn't it? A is diametrically opposite to B, or otherwise we can say B is diametrically opposite to A. So the angle formed between these two lines is known as, these two lines of sight is known as parallax angle, theta. So this theta is equal to 1 arc second. This theta is equal to 1 arc second. The distance to the astronomical object. The distance to the astronomical body or object from the sun, whose parallax angle is equal to 1 arc second. What is 1 arc second? Arc second, arc minute, this is same as second and minute. Arc second is same as second and arc minute is same as minute. Yes, there is no difference between these two units. These two units are one and the same. Since here we are dealing with arc, yes, we use the unit arc second. We use the unit arc minute. Yes. So what does it mean 1 second? What does it mean 1 minute? What does it mean 1 minute or what does it mean 1 second? We know around a point the total angle is 360 degree, isn't it? Around a point or at a point the total angle formed is 360 degree. Yes, we can say 361 degree. 361 degree forms 360 degree. Is it clear? 361 degrees, that is, this whole 360 can be divided into equal 360 parts, equal 361 degree parts, isn't it? Yes. and this measurement is known as 1 degree. Now, this 1 degree can again be divided into 60 minutes. That is, we can say 1 degree is equal to 60 into 1 minutes. That is, I can divide this whole 1 degree into 60 equal parts. 60 equal parts, and the measurement is equal to, and the measurement of each part is equal to 1 minute. Again, I can divide this 1 minute, again into 60 equal parts, 60 equal 1 second part. Is it clear? We usually represent minute by using a single line, minute by using a single note, single quote, and we represent second by using double quotes. Say for example, it is given 25 double quotes, it means 25 seconds. If it is given 52 single line, what does it mean? It means 52 minutes. Is it clear? Yes. So we can divide, we can say 360 degree is equal to 361 degree, and 1 degree is equal to 61 minutes, and 1 minute is equal to 61 second. So what is 1 degree is equal to 1 second? We know 1 degree is equal to 61 minutes, and again, yes, we know 1 minute is equal to 61 second. Is it clear? 1 degree is equal to 61 minutes, and again we know 1 minute is equal to 61 second. So I substituted 1 minute, by the value, by the number 60 into 1 second. So what is 1 degree is equal to? We can divide 1 degree into 3600 equal parts. We can divide, when we divide 1 degree into 3600 equal parts, the measurement of the angular measurement of each equal part is equal to 1 second. Is it clear? Yes. So what is parsec? We know when the angular measurement, when the parallax angle formed is equal to 1 arc second. The distance to the astronomical body from the sun, when the parallax angle formed is equal to 1 arc second, or simply 1 second. What does it mean? That is equal to 1 degree divided by 3600. Yes, I am dividing the whole 1 degree into 3600 equal parts. 3600 equal part. The measurement, the angular measurement of each equal part is equal to, the value is known as 1 arc second, or simply 1 second. Yes, it's one and the same. There is no difference. Is it clear, guys? Parsec? Yes. So now let's see conversion of units in angular measurements. Yes, conversion of units in angular measurements, and this conversion this conversion is very, very important. Yes, suppose we know the SI unit of angle is radian, isn't it? The SI unit of angle is radian. And here in this case, yes, we know theta is equal to arc length divided by radius. Theta is equal to arc length divided by radius. Here in this equation, there are some conditions. That is, the value or the unit of the angle theta, should always be in radians. The unit of the angle theta should always be in radians, and the unit of arc length should be in meter. Arc length and radius should be in meter always. Is it clear? Yes. So when we substitute values in this particular equation, the unit of the angular measurement, or the angle should always be in radians. The angular measurement should always be in radians. And the unit of both arc length and radius should always be meter. Is it clear? Yes. So suppose if the angular measurement is given in degrees, say for example 45 degree. Say for example 145 degree. Yes. So we have to find the angular measurement. We have to find this particular angular measurement in radians. In order to substitute in this particular equation. In order to substitute the value of the angle in this particular equation. So how do we convert? We know 1 degree is equal to pi by 180 radian. Isn't it? Yes. 1 degree is equal to pi divided by 180 radian. It is given, or we wanted to find, we are asked to find what is 145 degree in terms of, what is 145 degree in radians. So, yes, it is very easy to find the value, isn't it? Because we know what is 1 degree is equal to. Yes, to make this value, to make this 1 degree into 145 degree. To make this 1 degree into 145 degree, we know simply we have to multiply 1 degree by 145. So we get 145 degree. So since I am multiplying 145 on the left side of the equation, I have to perform the same operation on the right side of the equation. So that is equal to 145 into pi divided by 180 radian. So that is equal to 2 balance 4 9 29 pi divided by 30. 29 pi, not 30. 36. 29 pi divided by 36. So what is 145 degree is equal to in radians? 145 degree is equal to 29 pi by 36. Now you can substitute this particular value. Now you can substitute this particular measurement in this equation. Yes. Now suppose the value is given in minutes. Suppose the value is given in minutes. Say for example 29 minutes. Yes. So 29 single quote. What does it mean? It means 29 minutes. I have to find the value in radian. Yes. We know 1 degree is equal to pi by 180 radian, isn't it? Yes. And again we know 1 degree. We know 1 degree is equal to 60 into 1 minute. Yes. Isn't it? Yes. What is 1 degree is equal to in minutes? 1 degree is equal to, we can divide 1 degree into 60 equal parts of 1 minute. Yes. So, I substituted 1 degree. I substituted 1 degree by 60 into 1 minute, which is equal, that is equal to pi by 180 radian. Now I have to find what is 1 minute is equal to. 1 minute is equal to pi divided by 180 into 60 into radian. Is it clear? Yes. That is equal to pi divided by, what is 180 into 60? 18 into 6 into 100. That is equal to 9 into 12 into 100. 10800. Yes. 10800 radian. So what is 1 minute is equal to? 1 minute is equal to pi divided by 10800 radian. Is it clear? Yes. So now we have to find what is 29 minutes in radian. 29 minutes in radian. So I know 1 minute is equal to pi divided by 10800 radian. Yes. Here I have to find what is 29 minutes is equal to. Yes. Here it's given 1 minute is equal. So it is very easy to make. 1 minute into 29 minutes. I have to simply multiply the 1 minute by 29. Is it clear? Yes. So I will get the value 29 minutes. Since I am multiplying 29 on the left side of the equation, I have to perform the same operation on the right side. Yes. So 29 into pi divided by 10800 radian. So what is 29 minute is equal to? 29 minute is equal to 29 into pi divided by 10800. Yes. Say for let it be 30. Okay, let it be 30. So we can solve. Yes. So I can solve this 0 cancelled. Pi divided by, again we can cancel 108 and 3. So pi divided by 360. Pi divided by 360. So what is 30 minutes is equal to? 30 minutes is equal to pi divided by 360 radian. Now you can substitute. Now you can substitute this theta by this particular value. If suppose the value is given in seconds. If suppose the value is given in seconds. Yes. Suppose 30 minutes, 30 seconds, not 30, let it be 40. 40 seconds. Suppose the value is given in seconds. Yes. So here we have to find the value in radians. I know 1 minute is equal to pi divided by 10800 radian. Is it clear? Yes. Again, we know 1 minute can be again divided into 60 equal parts. 60 equal parts of 1 second. So what is 1 minute is equal to? 1 minute is equal to 60 into 1 second. That is pi divided by 10800. So now what is 1 second is equal to? 1 second is equal to 60 pi divided by 10800 into 60. Yes. So what is 10800 into 60? 108 into 6 into 1000. Yes. Here 100 plus 8. 100 plus 8 into 6, that is 600 plus 48. So it is equal to 648,000 radian. It is equal to 1 second is equal to 648,000 radian. Yes. Is it clear? Yes. So we know 1 second is equal to pi divided by 648,000 radian. Now we have to find what is 40 second is equal to. So it's very easy to make 1 second into 40 second. I have to simply multiply by 40 second. Simply multiply this 1 second by 40. Since I am multiplying 40 on the left side, I have to multiply the same value on the right side also. Yes. Now 0 cancel. Again I think we can cancel 4 and 648, isn't it? Yes. 16, 16200. So pi divided by 16200 radian is so 40 second is equal to pi divided by 16,200 radian. So now you can substitute this value in this. Now you can substitute this theta by this value. Is it clear, guys? Yes. Suppose it is given in degrees, minutes and seconds. Suppose it is given in, the angular measurement is given in degrees, minutes and seconds. Say for example 54 degree, 22 minutes, 35 seconds. If suppose the angular measurement is given in, either these 3 units or in any of the 2 units, that is say for example 54 degree 22 minutes or else 54 degree 35 seconds, otherwise 22 minutes 35 seconds. If it is given like this, then you can follow 2 methods. You can follow 2 methods to convert these angular measurements into radians. That is, the first method is either Either you can convert, what does it mean? What does it mean? 54 degree, 22 minutes, 35 seconds. What does it mean? It means 54 degree plus 22 minutes plus 35 seconds. Is it clear? Yes. If the angular measurement is given like this, it means 54 degree plus 22 minutes plus 35 seconds, and here the operation performed is addition and not multiplication. It's wrong. Is it clear? Here the operation performed between these values is addition and not multiplication. Yes. So if the value is given like this, either you can convert these values separately like this, directly into radian. Either you can convert these values separately directly into radian. That is, we know 1 degree is equal to pi divided by 180 radian. Again, what is 1 minute is equal to? 1 minute is equal to 10800 radian. What is 1 second is equal to? Pi divided by 64800 radian. So, yes, to convert degree into radian, yes, we have to simply multiply the degree value or the given value by pi divided by 180. Pi divided by 180 plus, again, to convert the value, the angular measurement given in minutes into radian, yes, we have to multiply the given value by pi divided by 10888 radian. Again, to convert second into radian, yes, we have to multiply the given value by pi divided by 64800, and the unit of this whole value is radian. Whole angular measurement is radian. So when we solve this, we will get 6 pi 6 pi divided by 20, isn't it? 9, 6 are 20. So we get 3 pi divided by 10. 3 pi divided by 10 plus 11 pi divided by 5400. Again here 35. 7 pi divided by 648 into 20. So 16. Balance 1, 9, 12. 12960. Yes. So 7 pi divided by 12960 radian. So once you solve or once you add all these values, yes, you will get what is 54 degree, 22 minutes, 35 seconds in radian. Is it clear, guys? Yes. Let's see one more example. And then let's discuss the second method for the conversion. The first method is comparatively easy. Among these two methods, the first method which we discussed now is comparatively easy. Yes, comparatively easier. So say for example, 90 degree, 30 minutes, 54 seconds. 90 degree, 30 minutes and 54 seconds, and we have to find the particular value in radian. So here I am going to convert each angular measurement separately into radians. So to convert degree into radian, yes, I have to simply multiply the given value by pi divided by 180. To convert minute into radian, I have to simply multiply the given value by pi divided by 10800 radian. Again, to convert second into radian, I have to simply multiply the given value by pi divided by 64880, and the unit of this whole angular measurement is radian. So when I solve this, I will get pi by 2 plus pi divided by 360 plus again if I divide by 9, if I divide by 9, here I will get 6 and here I will get 7 balance 1, 7200. Again if I divide it by 6, I will get 1200. Yes. So pi divided by 1200. If I add all these values, yes, I will get the so and so angular measurement in radian. So here I can make this value 1200 by multiplying 600. So 600 pi divided by 1200 plus 360. 360 into 5, it's 180. Okay, yes. This much is enough for now. Yes, if you add all these values, yes, you will get what is 90 degree 30 minutes 54 seconds in radian. Is it clear? Yes. Now let's see the second method. Second method is a little more complicated than the first method. Yes, told before, first method is comparatively easier. So I always prefer to the first method, to the second method. Yes. So the second method is nothing but the first step of the second method. The first step of the second method is to convert the whole value, into a single unit. That is, either we can convert all these values into degrees, or we can convert all these values into minutes, or we can convert all these values into seconds. Then you can convert the particular value into radian. So the second method has two steps. So the very first step is to convert the given value into a single unit. That is, say for example, firstly I'm going to convert all these values into degree. So 90 degree, let it be as such. And I have to convert 30 minutes into degree. Yes, I know 1 degree is equal to 60 minutes. That is equal to 60 into 1 minute. So here in this case I have to find what is 30 minutes is equal to in terms of degree. So from this equation I have to find what is 1 minute in terms of degree. So 1 minute is equal to 1 divided by 60 degree. So I got 1 minute is equal to 1 divided by 60 degree. So it is very easy to make this 1 degree and this 1 minute as 30 minutes. I have to simply multiply by 30. So since I multiplied the number 30 on one side of the equation, I have to multiply, or I have to perform the same operation on the other side also. So on the other side also I am multiplying by 30. So I got the value half degree. So what is 30 minutes is equal to? 30 minutes is equal to half degree. Then next I am going to convert 54 seconds. Next I am going to convert 54 seconds into degree. Yes. So I know 1 degree is equal to 3600 seconds. That is equal to 3600 into 1 second. So here I have to find what is 54 seconds is equal to in degrees. So from this equation I have to find what is 1 second is equal to 1 divided by 3600 degree. 1 divided by 3600 degree. Yes. So I got what is 1 second is equal to. From this equation I can find what is 54 seconds is equal to by simply multiplying by 54 seconds. 1 divided by 3600. If I cancel I will get 6, 400. Again if I cancel I will get 3 divided by 200. So what is 54 seconds in terms of degree? 3 divided by 200 degree. Is it clear? Is it clear guys? Yes. Yes. And one more point which you should always remember, that is What does it mean? What does it mean? 90 degree 90 degree 30 minutes 54 seconds. It means the total angular measurement is 90 degree plus 30 minutes plus 54 seconds. Is it clear? The operation which we are performing here is nothing but addition, and it's not multiplication. It's not multiplication. The action or the operation we are performing here is simply addition, not multiplication. Is it clear? Yes. You should remember it always. Here we are not multiplying these values, but here we are simply adding these values. Yes. So when we add 200, okay. So I am going to multiply by 200 throughout, plus 200, here 100, plus 100 plus 3 divided by 200. So the value is in degree. 90 into 200 means 18,000 plus 100 plus 3. So 18103 divided by 200 degrees. So the total angular measurement of this particular value in degrees is 18103 divided by 200. So now I am going to convert this particular value in degrees into radian by simply multiplying pi divided by 180. So this is the second step. This is the second step of the second method. So what is the first step of the second method? The very first step of the second method is to convert all the values into a single unit. All the values into a single unit. You can find it in degrees or seconds or minutes, whatever, based on the values given. Yes. After converting these values into a single unit, then you can convert the given value or the value you found in degrees or minutes or seconds into radian by simply multiplying by these values based on the unit. Is it clear? Yes. Now let's try to convert all these values into minutes. And then we find what is in terms of radian. Yes. So here I know 1 degree is equal to 60 minutes. So what is 90 degrees in terms of minutes? That is nothing but 90 into 60 minutes. So 90 into 60 minutes. And 30 minutes, let it remain as such. And again here I know 1 minute is equal to 60 seconds, isn't it? 1 minute is equal to 60 seconds, that is equal to 60 into 1 second. Here in this case I have to find what is 54 seconds in minutes. So from this equation I have to find what is 1 second is equal to. 1 second is equal to nothing but 1 divided by 60 minutes. So what is 54 second is equal to? 54 second is equal to 54 into 1 divided by 60 minutes. Is it clear, guys? Yes. So if I solve all these values, if I add all these values, yes, I will get the angular measurement in minutes, isn't it? Yes. So let's see, 90 into 60 means 5400. 5400 plus 30 plus, here I will get 9 by 10. 9 by 10 means 0.9. Here I will get 0.9. So what is the angular measurement? What is the given angular measurement in minutes? It is nothing but 5430.9 minutes. Now I am going to convert this particular value in minutes into radian by simply multiplying this value by pi divided by 10800 radian. Yes, once I find the product of this, I will get the angular measurement in radian. Is it clear, guys? Yes. Now let's try to convert all the given values into second. So I know 1 degree is equal to 3600 seconds. So what is 90 degree is equal to? I have to simply multiply 90. I have to simply multiply 3600 by 90. So, and what is 30 minutes is equal to? I know 1 minute is equal to 60 seconds. So, what is 30 minutes? 30 into 60. Again, let 54 seconds remain as such. Yes. Now, if I solve all these, if I add all these values, as I will get the value in second. 36 into 9. 360 minus 36, 144. Not 144, sorry. 324. Okay. 324 not 00, 000. 324 000 second plus. Here I will get 1800 second plus 54 seconds. Yes. 324 1800 54. 4 5 12 4 3. So the angular measurement, the whole angular measurement in second is nothing but 34254. So now I am going to convert this particular angular measurement in seconds into radians by simply multiplying the value in second by the number 64800 radian. Is it clear, guys? Not 00, it will be 000. Sorry, yes. Simply by multiplying pi divided by 64800 radian. Is it clear, guys? The conversion of units, of angles? Yes. So you can follow any of these two methods for the conversion. You can follow any of these two methods. I always prefer the first method to the second method, because first method is comparatively easier than the second method. Yes. So now let's discuss some problems on parallax method.